BA Geography, Semester 6, Module 1, GIS Definition and History of GIS. Objectives. In this chapter, we will get to know about definitions of GIS, history of GIS, GIS past, present and future. Introduction. To answer apparently simple geographical questions like what is population of the city, what are the characteristics of the soils in a particular area, are there any trends and patterns of earthquake in India which could help predict future earthquakes, how has the distribution of industries location has changed in 2 decades. All these questions are pertinent and require proper and accurate data derived from several sources and to be integrated into consistent form. The art, science, engineering and technology required to answer these geographical questions constitute called Geographical Information System GIS. GIS is a generic term denoting the use of computers to create and depict digital representation of the Earth's surface. Definitions of GIS. A geographic information system is designed to capture, manipulate, store, analyze and manage data. It is an extension of cartography, the science of making maps, and allows individuals to visualize, analyze, question and interpret data. Geographical information system is a framework for gathering, managing and analyzing data. Rooted in the science of geography, GIS integrates many types of data. It analyzes spatial location and organizes layers of information into visualization using maps and 3D scenes. GIS reveals deeper insights into data such as patterns, relationships and situations, helping users make a smarter decision. GIS applications are tools that allow end users to perform spatial query, analysis, edit spatial data and create hard copy maps. In simple ways, GIS can be defined as an image that is referenced to the Earth or has X and Y coordinates and its attribute values are stored in the table. These X and Y coordinates are based on different projection systems, and these various types of projection system, most of the time GIS is used to create maps and to print. To perform the basic task in GIS, layers are combined, edited and designed. A GIS is a cartographic document in the sense they both contain examples of the base map where additional data has been added as necessary. There is no limit to the amount of data that can be added to a GIS map, which capitalizes on analyze and present data in support of arguments. History of GIS. In the early 20th century, a printing technique called photozincography introduced, which allows users to separate layers from a map. This technology meant different themes could be printed, but it did not represent a full GIS since there was no opportunity to analyze mapped data. There have been 4 distinct phases in the development of geographic information systems. Phase 1, between the early 1960s and the mid 1970s, saw a new discipline being dominated by a few key individuals who were in a shape the direction of the future research and development. The second phase, from the mid 1970s to early 1980s, saw the adoption of technologies by national agencies that led to a focus on the development of best practice. Phase 3, between 1982 until the late 1980s, saw the development and exploitation of the commercial marketplace surrounding GIS, with the final phase since the late 1980s has seen a focus on the ways of improving the usability of technology by making facilities more user-centric. The early 1960s to 1980s was really the time period of GIS pioneering. The PCs were coming together with advancement in technology. Map graphics as an output using line printers, advances in data storage with mainframe computers, recording coordinates as data input. These initial development in the world of computing are what propelled GIS its next forward. But what GIS really needed was a brilliant mind to put the puzzle pieces together. The first documented application of what could be classed as a GIS was in France in 1832. French geographer Charles Picquet created a map-based representation of cholera epidemiology in Paris by representing the 48 districts of Paris with different half-tone color gradients, an early version of a heat map. Rapport sur la marche et les effets du choléra morbus dans Paris is likely the first use of spatial analysis in epidemiology. 1832 shredded map showing cholera deaths per 1,000 inhabitants for each of the 48 districts in Paris by Charles Picquet. A similar situation led to John Snow depicting cholera deaths in London using points on a map in 1854. The Snow map was important because it was just not a presentation of data. An attempt was made to present an argument developed from a spatial analysis of data displayed on the map, and it is offered as one of the earliest examining of geographic inquiry in epidemiology. John Snow 1854 cholera map, the next significant step in the development of modern geographic information system, was in the early 20th century. A printing technique known as 𝗧𝗦𝗔𝗧 was used to separate out layers from a map. Vegetation, water, developed land could all be printed as separate themes. While giving the appearance of being a GIS, this does not represent a full GIS, as there is no opportunity to provide an analysis to a mapped data. First GIS. By the 1960s, the nuclear arms program has given rise to hardware and mapping application, and the first operational GIS had been launched in Ottawa, Canada. This early iteration of GIS was developed to store, collate and analyze data about land usage in Canada. The system was enhanced throughout the 70s and 80s until the mid-90s, by which time it was driven by mainframe hardware and contained data sets from entire Canadian landmass. Enter Roger Tomlinson, the father of GIS. It was during Roger Tomlinson's tenure with the Canadian government in 1960s when he initiated, planned and directed the development of the Canadian Geographical System (CGIS). This was a key time in the history of GIS because many consider CGIS as the root of geographical. CGIS was unique because it adopted a layer approach system to the map handling. Because of the vast amount of territory Canada occupies, the idea for a Canadian land intervention developed in 1964, but it wasn't until 1971 that it became fully operational. The Canadian land inventory used soil, drainage and climatic characteristics to determine land capability for crop types and forested areas. It quickly recognized that accurate and relevant data was vital to land planning and decision making. Over the years, CGIS has been modified and improved to keep pace with technology. The CGIS wasn't the only group adopting GIS. The US Census Bureau was an early adopter of some of the core principles of GIS. It was the pioneering work by the US Census Bureau that led to the digital input of 1970 census using the data format GBF-DIME, Geographic Base File Dual Independent Map Encoding. GBF-DIME became a file format that supported digital data input, error fixing and even choropleth mapping. Using this format, the US Census Bureau began to digitize census boundaries, roads and urban areas. This was a huge step forward in the history of GIS. The Ordnance Survey in the UK also started their routine topographic map development. To this very date, the Ordnance Survey is still producing many different GIS data products including every household, every fence and every stream in every single part of Great Britain. At this point in the history of GIS, it was in its pioneering stage. It was still on its training wheels, beginning to be fostered by only a selected few national agencies around the world. (1975 to 90) GIS software commercialization. As governments realized the advantages of digital mapping, this influenced the work of the Harvard Laboratory Computer Graphics. In the mid-1970s, Harvard Laboratory Computer Graphics developed the first vector GIS called 𝗬𝗏𝗧 GIS. 𝗧-𝗏-ARC-Info used the technical framework from 𝗬𝗏𝗧 GIS, and this work led to the next stage of development in GIS software commercialization. In the late 1970s, memory size and the graphic capabilities were improving. New computer cartography products including GIMS, Geographic Information Making and Management System, MAPIX, Surface, Grid, ImGrid, GeoMap and MAP. In the late 1980s, this segment of GIS history was marked by an increasing range of GIS software vendors. One of these GIS software vendors was 𝗧, which is now the largest GIS software company in the world. In 1982, ARC-Info for mini computers was launched, and in 1986, PC ARC-Info was launched with the production of the Intel microcomputer. 𝗧 is now the world's leading expert in GIS software development, and it has played a key role in history of GIS. At this point in the history of GIS, it also gained steam with some of the first conferences and published work. The first GIS meeting in the UK was in 1975. It included a small crowd of academics. The first GIS conference was in 1981 and attracted a crowd of 18 participants. GIS consultancy started sprouting. Roger Tomlinson first used the term Geographic Information System in his publication in 1968, a Geographic Information System for Regional Planning. That was a really lonely time for GIS, but all of us users have made GIS what it is today, especially for the next time period. (1990 to 2010) User proliferation. Users are starting to adopt GIS technology in different ways. Classrooms, business, government around the world are starting to harness digital mapping and analysis. All the ingredients were ready for the infiltration of GIS to the people. Cheaper, faster and more powerful computer, multiple software options and data availability, the launch of new satellites and integration of remote sensing technologies. 1990 to 2010 was a period in the history of GIS when it really took off, but advancement in technology have surpassed the average users. GIS users didn't know how to take full advantage of GIS technologies. Companies were hesitant to adopt GIS software. Countries didn't have access to topographical data. Gradually, the importance of spatial analysis for decision making was becoming recognized. Slowly, GIS was being introduced to classrooms and companies. Software was able to handle both vector and raster data. With more satellites being launched into orbit, this data collected from space could be consumed in GIS. This, in unison with the availability of global positioning system, gave users more tools than they ever had before. Like the flicker of a switch, GPS selective availability was turned off. Suddenly, accuracy had changed from size of an airport to the small size of shed. GPS has led the way to great innovative products like car navigation system and unmanned aerial vehicles. The floodgates for GIS and GPS development has begun open. This brings us to our next stage of development in the history of GIS, the open source explosion. (2010) to onwards, the open source explosion. With users getting accustomed to GIS software, this has sparked a new revelation in GIS, an open source explosion. Amazing projects like QGIS are providing any user with a computer with GIS software. Processors are now in gigahertz, graphics cards are crisper than they ever been before. We now think of GIS data storage in terabytes. It's no longer megabytes. GIS data has become more ubiquitous. Tiger data, Landsat satellite imagery and even LiDAR data is accessible to download for free. Online repositories like ArcGIS Online store massive amount of spatial data. It's a matter of quality control and fitting it for your needs. The range of commercial GIS software products out there seems endless, but what stands out is the big shift of GIS users building their own GIS software in an open, collaborative way. This software is made available to the public and is called open source. The big plus is they are for public use at no cost. Open source is becoming mainstream today. We are gradually entering an era of open source GIS software. More light is shining on QGIS than ever before, even though there will always be a place for commercial GIS software. Software companies like 𝗧𝗦𝗔𝗧 provide solutions to practically any spatial problem that exists today. GIS past, present and future. The history of GIS is composed of three historic stages: pioneering and development, GIS software commercialization, user adoption. As time went on, GIS became a computer based tool for storing and manipulating map based land data. It's now a multi-billion-dollar industry responsible for some of the most important decisions our earth is facing. Five things that brought the changes in GIS. The world moved from desktop to servers to the web and then to the mobile. As the technology progressed, GIS also took this transition. GIS moved from being a big desktop software to be a server based, to a web GIS and now to mobile GIS. But what made the change is that need for the people to take advantage of the power of maps, the power of location, intelligence, the power of geography. Here are the aspects that brought this change. You no more capture, create, edit base maps to visualize. Since the availability of base map as web services, the hectic task of creating base data first slowly started to diminish. You no more need to install a GIS. Since the cloud and SaaS model started to get popular, GIS is always there for you and for your enterprise. It always up to date. You don't need to store it. It always available as per your demand on PC, mobile or tablet. Enterprises are taking the advantage of cloud storage model of data. You don't need to run tools to analyze data. Rather than the need for the business data to come to GIS, the GIS started getting integrated with the business data, processes and workflows. Instead of running the toolbox or the script to do the analysis, the logic for the analysis is already predefined and the analysis can even happen over the cloud. If you don't have the logic, you can always buy the tool as an app in the cloud and run it. You no more create map layouts every time to visualize the data. Preset map styles and templates are available within the GIS that help you to open the template and visualize the data. You can also share and publish these results easily and tell stories with your data. Summary. Geographical information system is information about geography, that is, information tied to some specific set of location on the Earth's surface, including the zone of atmosphere. Today, the term GIS tends to be applied whenever geographical information in digital form is manipulated, whatever be the purpose of the manipulation. Thus, using a computer to make a map is referred to as GIS. GIS might provide the medium for studying one or more of the fundamental issues that arise in using digital information technology to examine the surface of Earth or related systems.